Okay, now this kind of algebraic fraction is a little bit special, and there's going to be a new rule introduced here. Up till now I've effectively said start with the numbers and simplify the numbers as though they were a normal fraction, then look at the letters. Well, if we try to do that, we'd be simplifying 6 over 2. And very often when people are shown a fraction like this one, that's exactly what they do. They say, right, 6 divides by 2, so this must be the same as x squared minus 3. But it's not. That's all wrong. You can't do that. The reason we can't do that is because this whole fraction here is really, or another way of writing it is, x squared over 2 minus 6 over 2. So if you'd written it in this form, then yeah, you could go ahead and write that as x squared over 2, and now you can simplify that part and make it 3. But that's not the same thing as just x squared minus 3 on its own. This is something else. So you can't just look at that whole fraction and say, yeah, I'll cancel the 6 with the 2, it doesn't work, you're not allowed to do it. It's different because we have two terms on top. We have a binomial on top here, whereas up until now we've always had monomials, single term on top, single term on the bottom. That has now changed. And so if you're going to simplify the numbers, you have to simplify the numbers in every single term, top and bottom. So you can only simplify the numbers if you can find something that would divide into each term. And as it happens, we don't have a number in front of the x squared here, or what we have is the secret 1, but there's no number that's going to divide into 1 and 2 and 6 other than 1. In fact, we basically cannot simplify this at all. That's as simple as it gets, and we pretty much just have to leave it like that. By contrast, if we look at this fraction, well, we can find something that divides into 4, 6, and 2. And that's just the number 2. So 4 divided by 2 is 2, and we still have the x squared, and 6 divided by 2 is 3. So this time we could simplify it. Now just like before, we will start by looking at the numbers. I've got a binomial on top, 2 terms, and I've got 1 term on the bottom. So I'm going to start by looking at the numbers. I've got a 3, a 5, and a secret 1. Is there anything that can divide into all 3 of those? No. So I can't simplify the numbers. Next I will look at the letters. Well, this term has x squared in it, this one has x, and this one has x as well. So they all have an x in them, so we can simplify the letters. This x and this x are going to cancel out completely, and this 2 is going to become a 1. So we end up with 3x over 5, but we're not quite done yet. When I said this x cancelled out, what I really meant was x divided by x is 1. And because there's nothing else left in that term, we still have to write that 1 in. We still have to write plus 1. We've got a fraction now that it's starting to look a little bit messy and a little bit complicated compared to what we've seen up till now. But by breaking it down and looking at everything one bit at a time, we can still simplify this, and the process is not that difficult. As before, start by looking at the numbers. So this term has a 6 in it, this term has a 2, and this term has a 2 as well. So we can divide each of those numbers by 2, that's the biggest number that will go into each of them. So we'll have a 3. That would just leave us with a plus 1 in this term, and that would just leave us with a 1 on the bottom as well. So I'm going to leave those ones for now, we might have to write them in later. Next I'm going to look at the x's. Now this term has x squared in it, and this term has x to the power of 4 as well. This term doesn't. That's important. That means that we cannot simplify or cancel out any of the x's, none of them at all. We can't even simplify these two, and that is the very, very common mistake that people make. We can't do it. We have to have an x in all three terms, or we can't simplify. So we leave the x's. So we are going to have x squared on top, and we are still going to have x to the power 4 on the bottom. Looking now at the y's, we have a y in every term, so that will go completely, that will cancel completely, and that will become y to the power of 1. So in this term, when I said that disappeared, it just became 1. So there's no need to write it in. And now for this term here, we said 2 divided by 2 was 1. That's become a 1 as well. 1 times 1 is just 1. In this final example, we now have a trinomial. On top, we've got 3 terms, and we still only have 1 term on the bottom, so we have a monomial on the bottom. As before, start with the numbers. 4, 2, 6, and 2. Each of those will divide by 2, that's the biggest number that will go into each of them. So we're going to have 2, that term would give us 1. In fact, I might instead of write some of these in there, just to make it a bit easier. 2, 1, 1, and 3. Now let's look at the x's, and I'll write this bit in all at the end. I have an x in this term here, x squared. There's x to the power 1 in this term, x to the power 5, and x to the power 1 in the denominator. So we can simplify or cancel out all of the x's. That one will go completely. That becomes x to the power 1. That cancels out. And that becomes x to the power of 4. Finally, looking at the y's, well, straight away I can see I don't have a y in this term here. So I can't do anything with the y's, I can't simplify them. The same is true of this r on the bottom. There's no r's in any of these terms, so I can't do anything with that either. So I'm left with 2x, this is 2x to the power 1, and then 1y cubed, and then we have negative 3 yx to the power 4, and that's all over 1 r y. Here are 4 more algebraic fractions where you have more than one term in the numerators. In a moment, pause the video and use your mini whiteboard or a sheet of paper to try to simplify each of the fractions. When you're ready, press play again and the simplifications will appear one at a time for you to check.